Okay, welcome back. And we're on almost when it's angles in same seg already. We're on something which might be slightly new for some of you. Now, non-maths question to start off with. What makes me unhappy about these reasons? And it's in there and it's in there. It's those apostrophes. What are they there for? So I'm going to get rid of those because they're really annoying. Because why would you have an apostrophe? Doesn't belong to the angle. It's not like angles is. It's not like Mr. Uvrod's microphone. No, you can't see it. Or anyway. So I think we should be here. Let's check that everything's working. So angles. Now, just out of interest, are you in the camp that has got three options? Option 1, you use this reason. Option 2, you use this reason. Option 3, this is the first time you're seeing this, so you don't know any of the reasons and you're going to choose one going forward. Oh yeah, I'm in camp 2. I use this reason and it doesn't matter which one you use. Really doesn't. I just think angles in same seg. Remember, it's angles in same seg. That seems quite quick and easy to write. Okay, so if you saw the last video, we're going to do this one in a similar way in terms of the starting at 2 points. So if we start at point B and point C, just for argument's sake, let's see what angles we can create. Subtend. So we can create this angle at the circumference by going from B to A and from C to A. So the bit of like, you can get the idea of starting at B and C, we can create this angle A. Now let's do the same on this one. Maybe I'm in the way. So if we start at B and C, can we create any other angles, either at the center or the circumference? Remember, this isn't the center. It doesn't tell us. So let's see. Go from B. Let's go along this chord. We get to D. From C we also get to D. That's quite cool. We can create an angle. Now with this theorem, which is used, I don't know, it just feels like one of those theorems that comes up quite often in its use, says that these two angles, angle A and angle D, are equal. So this says, let's do it here and say angle A equals angle D, and your reason is one of these two. I'm always going to say angles in same seg. Okay, so that's what it does. So let's go through an example and see how this one works. So we've got this whole thing going on, and they kind of really want to go through this because they're two different ways you can kind of think of it. The one is to look at what you're given and see how that helps you move forward. The other way is to look at where you're trying to get to and work a bit backwards. And we're going to do each one. Let's start with what we're given. We're given this 18. Now, how do we create this angle? If we work backwards from H, what 2 points on the circumference do we go back to create this angle H of 18 degrees? Now, you might have answered, I don't know what you're on about. That's fine. Maybe you answered and said, well, I could draw this line backwards to get to E, and I could draw this line backwards to get to F. So there's that angle 18 degrees. So we've created it by going from E and F. Now we use that trick that we were using before. It's not really a trick, but it's a method. And say, are there any other angles we can create from E and F? Because if there are, we know that it's also going to be 18 degrees because of angles in same seg. So is there another angle that you can create at this circumference of the circle? Well, the answer is yes, and maybe I should have asked, and which angle is it? So let's go from E, let's keep going. Yeah, we can, that's when I press the button, by the way, and make a mistake. So we can go along here to G, and if we work backwards, we can, not that we're on, from F, we can also go along here. So notice, starting from E and F, we can create angle H, and we can create angle G. So therefore, those two angles must be equal to each other. So X equals 18 degrees. Reason? Well, I'm going to use angles in same seg. You may have used the other one. Equal something, something's equal. I don't know. It's too long for me. So there's the one. So that's the one way of doing it. We've taken an angle that we know and we've used it and said, how can that help us? Now let's do the opposite way to work out y. So let's do this and say, here's angle y. That's what we're trying to find out. Let's see are there any other angles equal to y? So to create y, starting from E, what 2 points on the circumference do you need to start at to create this angle here? Well, we need to start from H, because we've worked backwards from E to get there, and we need to go back here to G. Again, annoying. And we get there, cool. And we've got from H and G, and now we ask ourselves, is there another angle on the circumference that we can create from H and G? And what is it? Let's see. So if we go from H, we get up here to angle F. And because we started at H and G and we've created another one at F, and we go, great stuff, that's 22. In other words, those two are equal, so y equals 22. We've already written this reason. Do we have to write it again? Yes, we definitely do, because this statement, y equals 22, relates to this reason, or vice versa. This reason, angles in same seg, relates to this statement. So each statement needs its own reason. Okay, and there we are. Trick question. Is K, this angle HKG, can I say well, that's 22. So isn't it just angle at center equals twice angle at circumference, so that equals 44 degrees, right? No. Why can we not say that? Well, there's nothing to say that K is the center of the circle. So if your reason was going to be angle at center, you weren't told this is the center. O is the center. That's not O, that's K. So be careful about ideas like that. Okay, so to finish this video off, we've got something else. We've got X, and there's another angle equal to X, but we don't know that that's 35. What's in this diagram that is probably going to help us get there? That's a terrible question. I'm going to leave it in there to see what you wrote. I think that it's useful that we've got parallel lines, but you could just as well have said, well, parallel lines, whoop-de-doo, but hey, you've also got angles in same seg. That's something useful. You've got lots of angles on the circumference, etc., etc. You could have had lots of ways to answer that. I think it's useful that they're parallel lines as well. So they're going to be one of three that you're going to use. What are those 3 reasons that come to mind when you see parallel lines? And that's that one. Onwards, upwards. What do we have next up? Oh, actually, let's do this in this video. Sorry, this is the same idea. If you've got these things that are equal, then it means that the angles on the opposite side, should correctly do that, those angles are equal to each other. So equal chords subtend equal angles. Well, if those are the same, the angles across there, and this one's kind of a similar one. Well, if you've got equal, let's do this in yellow as well. If you've got equal chords, then if you create an angle at the center, well, clearly they just look equal, don't they? I mean, that's terrible logic, but they're equal. And there's a third one, and that is if the circles are exactly the same. So this one's saying equal circles means that circle, I'm not going to draw these very well, am I? That circle and that circle, if they're the same circle, well, then it just looks like this scenario all over again, doesn't it? Because the circles are the same. So if you've got these two being equal, then it seems to make sense that the angles across on the other side are going to be the same, because it's just like scenario 1. So those are useful ones. Definitely need to know them. And yeah, I've suggested give a few a go as you're going along. We're not going to go through any examples. We've done this one thoroughly enough. Okay,